Today we're going to look at combinations, but first we'll do a quick review of permutations, what we looked at yesterday. A permutation is when order matters. What that means is ABC is not the same as BCA. Here's an example of a permutation. What is the number of different ways 6 people can finish a race? So we looked at multiple methods for solving this. We can list out our 6 different people. There's 6 people to choose from that could get first place, and if you've chosen one, there's 5 people to choose from left that could get second place, and then 4, and then 3, and then so on, and you multiply them by the counting principle. That is the same as 6 factorial. Another way to represent this is a permutation order matter, so we could do NPR, and out of 6 people, we want to arrange all 6. And that answer is 720 different ways. What is the number of different ways 6 people can finish in the top 3 spots? So again, if you want to write it out, now there's only 3 spots. 6 people could get first place. There's 6 people to choose from that could get first place. Then there would be 5 people to choose from that could get second, and then 4. So we could do 6 times 5 times 4, or in your calculator is a permutation NPR. And out of the 6, we're just choosing for the top 3 spots. And if you do that, there's 120 ways to arrange 6 people in the top 3 spots. Let's do one more, a name one. What are all the different number of ways you can arrange the letters in the name Christina? So we could try that. Christina has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So this one we would have the total letters, but there's going to be some repetition here. What is repeated? Notice that I is repeated twice. So here it is going to be total letters. It's going to be the factorial of that over if there's any repetition. So 2 or anything that's repeated. Okay, so the number of different ways to arrange this one would be 9, the total letters, over the I is repeated twice, so 2 factorial. And if you do that, there's 181,440 ways to rearrange the letters in the name Christina. Let's try one where there's more than one letter that's repeated. So an example would be Mississippi. All right, in Mississippi, there are 11 letters. There's the total. All right, in Mississippi, the I is repeated 4 times. The S is repeated 4 times. And the P is repeated 2 times. So you could type that in your calculator, the total number of letters divided by all the repetitions, and we could arrange Mississippi 34,650 ways. So there's a review of permutations when order matters, but let's talk about when order does not matter and what that means. So here's a combination. A combination is when order doesn't matter. For example, if you go to a store and you order fries, a drink, and a burger, that's the same as ordering a burger, fries, and a drink. It doesn't matter what order you say it in, you will get the same thing. So this is when order doesn't matter. When you do something one way, it counts as if you rearrange it in another way. Example of a combination, we have Ariel, Bree, Carlos, and DJ are running to be the leaders of a committee. There are only 3 spots available. How many different 3-member committees can be formed? So it doesn't matter who wins, the top 3 people, what order they win in. They will be the 3 members of that committee. So this is a combination. And let's say we didn't know how to solve, we could make a list. So if we make a list, Ariel, Bree, and Carlos could win. That is the same as Carlos, Bree, and Ariel, so we're not going to write all the different combinations of A, B, and C. We could say, all right, Ariel, Bree, and DJ could win. Ariel, Carlos, and DJ could win. And then there's only one more, Bree, Carlos, and DJ could win. So really here, there's only 4 different ways that 4 people could become a 3-member committee. Okay, so that is an example of combination. Like in permutations, there's a formula for combinations. So let's write that down. All right, it is NCR in your calculator. You probably saw it yesterday, NCR. And there's a way to calculate that. This is the calculation your calculator's making. It's n factorial, or the number of total things factorial, over n minus r, the total number minus what you're choosing, factorial over r factorial. So in our calculator, this is the actual calculation it's doing.
Erica Merrick, please call 6000.
But this is if we have our calculator, this is what button we'll be using here. Okay, so in the Inspire, you press menu, statistics, combinations, NCR will pop up. Remember, N is total, R is the number of things you're looking for. So let's do an example of this. Let's say that you are going to a place like Good Day Cafe that makes omelets. And let's say you get to choose for your omelets how many different omelets you can make with 2 non-meat toppings and 1 meat topping. So your choices are 2 non-meat toppings and 1 meat toppings and 1 meat topping. How many different omelets are possible? Okay, so let's take a look at this right here. Let's start with the non-meat toppings and look at different combinations of that. So we have non-meat toppings. For non-meat toppings, if we count, there's 1, 2, 3, 4, 5, 6. So there's 6 different ways. So we have our NCR, and there's 6 to choose from, and we're choosing 2 of those. We're going to multiply by the 1 meat topping that we can choose. And out of the meat, there's 4. Oops, so I'll say NCR. And there's 4, and out of those 4, we can choose 1. So we're still multiplying things together, but we're separating it. We're doing the non-meat toppings first times the meat toppings. If you want to see what that looks like in the calculator, what your calculator is doing, it's 6 factorial over 6 minus 2 is 4 factorial times 2 factorial. And for the non-meat ones, it's 4 things total. Over you subtract 4 minus 1 is 3 factorial, and you're choosing 1 factorial. Or you can just type in your calculator. So let's do that. Let's do add a calculator. Menu, statistics, oops, let's hit escape. Probability, not statistics. Combinations, and the first one was 6 toppings. We're choosing 2 times menu. Probability, combinations, and out of the 4 meat toppings, we're choosing 1. So if you multiply that, there's 60 different omelets that we could do or create with 2 non-meat and 1 meat topping. So there would be 60 different combinations. Okay, let's look at more examples of combinations. Let's say you can get at most 3 toppings. How many different omelets can you make? All right, so this one we have a few things to think about. We could get an omelet with 0 toppings. We could get an omelet with 1 topping. We can get an omelet with 2 toppings. Or we can get an omelet with 3 toppings. Now, total toppings, so we're not dividing it into meat and non-meat, there's 10 total toppings. So the first one will be NCR, and out of the 10 we're choosing 0. Plus we have NCR, out of the 10 we're choosing 1. Plus NCR, out of the 10 we're choosing 2. Plus NCR, out of the 10 we're choosing 3. So there's only one way to choose 0 toppings to get a plain omelet, so 1. For 1 topping, there's 10 ways to choose an omelet with 1 topping. And again, you can get these by typing it in your calculator, just thinking there's 1 way to choose, or 10 ways to choose an omelet with 1 topping. For 2 toppings, though, there's actually 45 ways, 45 combinations. And for 3 toppings, there's 120 combinations. So there's going to be 176 different types of omelets you could create if you wanted at most 3 toppings. Next example. How many different ways can 2 co-chairs be selected from a class of 20 students? So again, it's co-chairs. So it's not a permutation. It's not like it's first place and second place. It's not like a president and vice president. It's 2 co-chairs, so it's a combination. Doesn't matter what order you pick them in. And from a class of 20. So this is NCR. Out of 20, you're choosing 2. And there's 190 ways to choose 2 people to be co-chairs from 20 students. So your assignments will actually be a worksheet where you go over, is it a permutation or combination, and how would you solve?